All right, everyone. Today we are going to be completing Lesson 6 in Booklet 7, that is more complex areas. Now, in this lesson, we are going to be finding the area, but not necessarily of one triangle, rectangle, or circle, but of a complex or an irregular shape. Consider example 1. This shape doesn't really have a name. Now, it kind of looks like a house that's on its side, but it's not a rectangle or a triangle or a circle. Instead, you might want to visualize it as multiple shapes that have been put together. So since there is no equation for the area of this, what I'm going to do is I'm going to draw a line along here. And what you can see is that this line has split the shape up into two smaller shapes that we can recognize. We have this shape that I'm highlighting in red, which is a rectangle. And we have this shape now that I'm highlighting in blue, which is our triangle. Now the idea is that if I find the area of the red rectangle and I find the area of the blue triangle and I add them together, what I will end up with is the total area of this shape. So I'm going to erase some of this busyness and replace it with proper form. I am going to write AR in this shape. AR stands for the area of the rectangle. And that allows me to differentiate between this A, which is going to be AT, the area of the triangle. So let's start by finding the area of the rectangle. Well, we know that the area of a rectangle is equal to length times width. Now, in this scenario, I directly give you the length and the width. That is 8 and 13. Please don't use the number 19. 19 is actually much larger than the length, right? It is the length plus some more. So 19 is not the length of the rectangle. It's longer than the side that it is along. So we're going to use 8 for the, well, let's use 8 for the width. We're going to use 8 for the width and 13 for the length. So the area of our rectangle is equal to 13 times 8. And 13 times 8 is going to give us what? 104 inches squared. Okay. Good. Now that we've calculated the area of the rectangle, the next thing that we need to do is find the area of the triangle. Now, in order to find the area of the triangle, we need to use the appropriate equation. And if you remember from earlier lessons, the equation for the area of the triangle is base times height divided by 2. Now, that might be a little bit harder to find on this picture, so let's take a closer look. I will do this in green. Now, the base of the triangle is that green line right there. And the base is going to be the same length as this line that's across the way. Right? You can see that it's the same gap, just farther down. So if the line on the left is 8 inches, then this line on the right also 8 inches. So good, we have our base. Now the height, that one's a little bit trickier. The height is the distance directly from the bottom of the triangle to the top of the triangle, right? In other words, if I was to use the line of the 19 inches above, it would be the distance from here to here. Now we can calculate that using similar skills that we did in the previous lesson. If this whole line on the top is 19, but we don't want this part of it, that's in red, then we can cut it out, right? We know that that red line is 13 inches because of this 13 inches down here. So, So we can find what's left of the line by taking the 19, subtracting the 13, and what's left is 6 inches. So, in other words, the base of our triangle is 8 inches and the height is 6 inches. That's a little bit tricky, so if it does not make sense, make sure that you're asking me so that I can explain it and clarify. So let's plug in what we know. Area equals base times height. The base is 8, the height is 6, so it's 8 times 6 divided by 2. The area of the triangle is 24 inches squared. Good. So now that we have the area of the rectangle and the area of the triangle, we can calculate the area total. I am going to use AT as a shorthand to represent the area, not of the rectangle, not of the triangle, but of everything, of them both put together. The area of the triangle is equal to the area of the rectangle plus the area of maybe I shouldn't use AT because we already have AT for triangle. Let me go back a step. The area total is equal to the area of the rectangle plus the area of the triangle. So the area total is equal to 104 plus 24. In other words, the total area is 128 inches squared. So there's quite a lot of work that goes into these questions. Make sure to number the order in which you're doing your math. First, we found the area of the rectangle, then we found the area of the triangle, then we added them together to find our total area. Let's take a look at question B. Again, there isn't really a name for this shape, so what we're going to do is we're going to break it up into smaller pieces into shapes that we do recognize. Now, in this question, the best way to do that is by drawing a dotted line across the bottom of that circular shape in order to make a rectangle at the bottom and a semicircle at the top. Now, a semicircle is just a circle that's been cut in half. Semi means half. So in order to calculate the area of the semicircle, we're going to use the equation for the area of a circle, which if you remember is pi times r squared. But then after we're going to divide it by 2 because it's not a full circle, it's only the top half of a circle. So we can divide that by 2. But we'll get to that a little bit later. Why don't we start by finding the area of the rectangle in the bottom half of this picture? So, step 1, find the area of the rectangle. Well, an area of a rectangle is found by length times width. In this situation, the length of the rectangle is 12, and the width of the rectangle is 8. So 12 times 8 gives me a number which is 96 feet squared. Check. That's the easy part. Next, we're going to find the area of the semicircle. Well, the area of a semicircle, as we mentioned earlier, is equal to the area of a circle. If you don't remember the area of the circle, just go back to lesson 5. You should have it circled here. It's right there. Area equals pi times r squared. So the area of the semicircle is equal to pi times r squared. But remember, it's not a full circle. It's a semi. It's just the top half. So we're going to take that area and we're going to half it. We're going to divide it by 2. Now, the only number that we need to find here is r, the radius. The radius of a circle or a semicircle, right? Draw a little pokeball there. The area of a circle is the distance from the middle to the outside. So that's this distance that I'm drawing here with these 2 arrows. Now, this entire length left to right is 8 feet. I know that because of the 8 feet down there. That's the diameter. I don't want the diameter, I want the radius. So I'm going to take that 8 feet, I'm going to divide it by 2. The radius of the semicircle is 4 feet. So the area of the semicircle is equal to pi times 4 squared divided by 2. Now, using a calculator, we know that 4 squared, or 4 times 4, is equal to 16. So this is like pi times 16 divided by 2. Now, you definitely need to use a calculator for this next step. Please remember that pi is 3.14. So 3.14 times 16 divided by 2 is 25.12. And that is feet squared. Good. So the final thing that we need to do is calculate the area total. And the total area is equal to the area of the rectangle underneath plus the area of the semicircle on top. So that is 96 plus 25.12, which gives us an answer of 121.12 feet squared. So this lesson can be quite tricky. Make sure that you're completing all of the worksheet. Make sure that you're letting me know if you have any questions and take your time with these examples. Thank you.